Hey there, science fans. Have you ever wondered how robots move with such precision and grace? The secret lies in a fascinating field called kinematics. Kinematics is like the science of motion. In robotics, it helps us understand and control how the different parts of a robot move together. Think of a robot arm, for example. Kinematics allows us to figure out the exact angles and positions of each joint to make the arm reach a specific point. Why is this important? Well, for robots to perform tasks accurately and efficiently, we need to know exactly how their movements translate to real-world positions. That's where kinematics comes in handy. Just like we need to understand the mechanics of our own bodies to move smoothly, robots rely on kinematics to navigate their surroundings and interact with objects. It's the foundation of robot movement and coordination. Now let's dive into a specific type of kinematics called forward kinematics. Imagine you have a robot arm with several joints. Each joint can rotate or move in a specific way. Forward kinematics helps us answer this question. If we know the angles of all the joints, what is the position of the robot's end effector, the hand of the robot? It's like solving a puzzle. We start with the base of the robot and work our way to the end effector. By using some cool math and trigonometry, we can calculate the position of each joint and finally the end effector. Forward kinematics is super useful in robotics. It helps us predict where the robot's arm will be after a series of joint movements. This is crucial for tasks like planning a path for the robot to follow or avoiding obstacles. Think of it like this. If you want to grab a cup of coffee, your brain uses forward kinematics to figure out how much to bend your elbow and wrist to reach the cup without spilling. Now, let's flip the script. Instead of predicting the end effector's position from joint angles, what if we want to do the opposite? What if we know where we want the robot's hand to go, and we need to figure out the joint angles to get it there? That's where inverse kinematics swoops in to save the day. Inverse kinematics is like working backward through the robot's structure. We start with the desired end effector position and use mathematical wizardry to calculate the necessary joint angles. This is super important for tasks like picking up objects, welding, or even performing surgery. By using inverse kinematics, we can program robots to perform precise movements and reach specific targets with ease. Imagine a robot arm assembling a car. Inverse kinematics allows the robot to accurately position its gripper to pick up a car part and then place it in the correct location on the assembly line. Kinematics is not just some abstract concept confined to research labs. It's the driving force behind countless real-world applications of robotics. From manufacturing and logistics to healthcare and entertainment, robots are everywhere, and they all rely on kinematics to move and interact with their surroundings. Think of the robotic arms used in car factories to weld and assemble vehicles with incredible speed and accuracy, or the surgical robots that assist surgeons in performing delicate procedures with minimal invasiveness. Even the robots that vacuum our floors or mow our lawns use kinematics to navigate our homes and avoid obstacles. Kinematics is the unsung hero of the robot world, enabling these amazing machines to perform tasks that were once thought to be the exclusive domain of humans. So, next time you see a robot in action, remember the power of kinematics. It's the science that brings these machines to life and allows them to move with precision, grace, and purpose. Keep those scientific minds churning, and I'll see you next time.